In this video, we're going to do an overview of the use of maps, when to use them, what we lose by using them, what we gain by using them, and illustrate kind of really what the use of a map is going to give you as a visualizer. Now, when we visualize maps, there's lots of different types, but the type that we usually are thinking about when we're visualizing a map is this one, which is the choropleth map. And all that means is that it uses a gradient of color to denote the quantitative element of interest. So this might be sales by state. And we see that it uses a single color gradient because it's a continuous value of data rather than rainbow colors. If we were doing things like, agricultural versus industrial dominant, we might use rainbow colors. But in this map, and the most typical map that we're going to be using and creating ourselves, is a choropleth map with a gradient to denote the quantitative element of interest. Now, the great thing about choropleth maps is it's a map, and most people understand what a map is. But choropleth maps can only represent the level of a single measure. And many of the other times we've been talking about building visualizations in this class, we've been talking about using multiple measures and how do we encode lots of different data into a visualization. And in a choropleth map, we're really looking at levels of one variable. Here's a great example of a map. It's got some color issues, but what do you think this map, this is just kind of fun, what do you think this map is visualizing? You can see that the red denotes lots of this happening in that area. The yellow denotes next to none in this area. And so what is common in some parts of the north part of the United States and kind of all over Mexico and Colorado? What can you think that might be? I'll let you think about it for a second. Well, I told you about the top part of Minnesota, that part that's all red. That's called the Iron Range of Minnesota. And there's not much to do there. My wife's family's from up there. And there's not much to do up there except mine ore and then go drink at night. There's also something called the Aurora Borealis that is often seen up there in the north part of Minnesota. So there's this phenomenon that's happening in the northern part of Minnesota. Now it's also happening in New Mexico, centered around a little town called Roswell. And so this is actually a map of UFO sightings in the United States. Now, the color is messed up, and the levels in the different buckets are really not very consistent, but this is just kind of a fun one that's using a two-color gradient map, which is not correct in this case, but it's illustrating something fun like UFO sightings. And we can understand some things about these numbers simply by knowing where they are happening geographically if we know about those geographic locations and the idiosyncrasies of those geographical locations. Why would something be happening just as often in the northern part of Minnesota versus the southern part of the United States in the middle of the desert in New Mexico? Well, when we know a little bit about Minnesota and we know about a little bit about New Mexico, we can make some inferences because we know where they are on the map. And we know the differences and why people might confuse, after having maybe a few too many drinks, confuse the Aurora Borealis with a UFO. And of course, the people go to Roswell to see UFOs, right? So, what do you think if we decide to use a map? And I'm not against maps, I love using maps. What are some of the general issues with maps? We've already discussed that there's a maximum of 6 dimensions that we can use in a two-dimensional map. We can use X and Y placement. We can use size, shape, color, and animation. How many of these do we lose when we're using a map? Can we change the XY placement of the states or the countries? No. Can we change the size or the shape of the countries? No. Now we can change the color of the countries. We just discussed that or the states of the different geographical units, whatever they are. We can change the color, and we know that that's called a choropleth map. Can we use animation? Not really, because when you're doing animation on a map, you can't see more than one slice of the animation. So you can't see where the animation's coming from or going to. And so we've really given away 5 of the 6 possible visual attributes that we can use to encode data. Now there's times when it's worth it. We just need to make sure that we understand when. So as we just discussed, one of the major issues with the map is that we've lost, for sure, the use of 4, but really 5 of the 6 dimensions. We could use animation, but it won't work well. So we've definitely lost 4, probably 5 of our 6 dimensions. Now here's the real problem. You've probably seen those man on the street things that people do. They show them pictures of countries or states, and people can't identify them. So a lot of people don't know their geography. And the other thing that we run into trouble with is that on the political map, some states are bigger than others. And remember, we use those visual attributes to have meaning. So size should mean more or more important. And so small little states like Rhode Island get ignored, and big states like Texas or Wyoming are looked at and paid more attention to simply because they're larger. All right? So maps use political boundaries, and although the boundaries are easily interpreted if you know your geography, they're hard to interpret because some even though they're small, might have more population than a bigger state like Wyoming. Rhode Island has far more people than Wyoming does, but it's tiny in comparison. All right? So what I want you to do right now is shut your eyes and then open them and look at this map and just figure out what your brain is doing. Where do your eyes start on this map and where do they go? So shut your eyes, look at the map, and be conscious of where your eyes start on the map and where they go. And I'll tell you that everyone basically starts in the center, but people really kind of go one of 2 different ways in general. They either go up to the darker area, to the predominantly darker area in the top right, or they go down to the predominantly large shapes of the left bottom. And and there's no right or wrong to this, it's just illustrating that some people perceive differences in size as being more important, and some people see the differences in color as being more important. All right? Now, what we've done is lost control. And at different times in this class, we're going to talk about trying to control the duration of even, but the order of especially, people's viewing of different parts of the visualization. So we want to be able to say, look here, then look here. And whenever we start using a map or anything that isn't arbitrary shapes like squares or bars, etc., when we start using shapes that have other meanings, like a map or an icon, etc., we start introducing different people's experiences, their different experiences, their different biases, and so we lose a little bit of control. All right? Now, I love using maps. I'm not saying don't use maps, but we have to understand their limitations and that we can show one level of one variable, although in the hands-on, I'll show how you can encode a couple other variables using some additional pieces as well. The other problem with maps is this. There was in the summer of 2016, the internet broke because this map, which is called the Mercator projection, was racist and white supremacist. And it had nothing to do with the choice of colors in this map. Now, some of you have probably heard this story before, but this map was considered racist because it underrepresented the size of Africa compared to other countries. And when you look at this map, Africa seems to be about the same size as South America and maybe even about the same size as Greenland. Now we know that Greenland is not nearly the size of Africa, and in fact that Africa can take the entirety of the United States, China, all of Western Europe and Scandinavia, Great Britain, and India and Argentina. And it's actually slightly larger than all of those countries put together. Africa is by far the largest landmass when we're talking about just the size in square kilometers, even more than Asia, if you don't count all of Russia, right? Like Southeast Asia, we tend to think of as being really, really big. It is big, but it's not nearly as big as Africa, all right? So, this was considered racist because obviously the chart maker was intentionally making other countries look bigger in proportion to Africa than they really are. Well, it's not really that. It's just because what we're trying to do with a map is take something that's three-dimensional and we're trying to turn it into 2 dimensions. And the way we do that is we wrap basically a cylinder around a globe. We put a light source in the center of the globe, and that light goes through the globe and projects onto the piece of paper or whatever we're going to write the map onto. And where the map is touching the globe, there's no distortion. But the only place that the map is touching the globe is the equator. And so only things that are within about 15 degrees of the equator are represented accurately. And you'll see almost all of Africa falls within that area of no or low distortion. Almost all of all the other continents falls outside of that area. South America falls mostly, about half in the area of 0 to 15 degrees, but all of Northern Europe, all of the United States, China, etc., all fall in that area of distortion. And so it's not that some map makers said we have to minimize Africa. It's that projections and 2D maps always distort. And so there's like, I once read a thing from an astronaut that the astronauts, when they go into space, say, oh, that's what that country looks like, or that's what that shape looks like, because it's very different than what they're used to seeing on maps. Now, there are some issues with maps, the aerial issues we call them, as far as political boundaries, bigger and smaller. And so some people have tried to solve this by doing some other kinds of maps. Now, we won't be building these in this class, but I wanted just to expose you to these. Now, cartograms, instead of changing the color of the map, they actually change the size, shape, and location of countries to indicate the difference in a level of a quantitative variable. So here's a different projection, slightly different projection than the one we were just looking at. Makes Africa look a little bit bigger. And so this is the non-distorted map. And then when I distort it into the cartogram by population, I see that China and India are bloated out of proportion to what they really are. And a lot of countries like Scandinavia and Russia are made small. Now, the problem with cartograms is that they're only interpretable when you compare them to the non-distorted map. So I take this map and I compare it like this, right? They also really need to be subject to our rule of standardization. Let's look at a few examples. We have population, child mortality, and obviously the places we would think have higher child mortality, like Africa and South Asia, have higher child mortality. But is it rates or is it numbers? This map is actually the number of children who die. And why would that be a problem? Because India has a huge population compared to most of the countries in Africa. So that might be distorted out of proportion. HIV infection. When I look at this map, I said, wow, we've all heard about the horrible HIV problem in Africa, but look at how bad it is in India. And it is bad in India. But again, these are incidence numbers, not rates, percentage of population. And so India has HIV infection, but they also have a huge population, so it's overstating their HIV infection problem compared to Africa. Not understating the importance of it, but it's overstating how it is in relationship to Africa. Healthcare spending. Now, this is a map that lots of people will turn to and say, look at the United States. What are we doing? We spend way too much money on healthcare, right? Look at our population. Look at our healthcare spending. It's kind of out of control. India and China aren't spending nearly as much on healthcare as we are. Energy consumption. Look at the horrible United States again, using too much energy. I mean, Japan's using a lot as well, but again, this kind of feeds the narrative of the United States is a bloated energy consumer compared to our population. But here's a map of GDP, and that GDP map looks a lot more similar to the energy consumption and healthcare spending maps than we might have previously thought, right? And so we've talked about this time and time again in this class, that standardization changes the story. And so we have to ensure that when we're presenting numbers, especially in a global world with interconnection between all kinds of different countries of all different sizes and shapes and levels of development, that we standardize where appropriate. All right? So the issues with the cartogram are new. We can't recognize the landmass at all anymore. And people already have issues with geography. How would presenting them something that looks like this, where we've turned the entire United States into something that kind of resembles a fish, help them understand the data, right? So we're gonna try. You can make cartograms in R and some other packages, but in Tableau we can only make choropleth maps, and this is kind of illustrating the reason why. All right. So you need to make sure, because audiences are different, you need to make sure that your audience understands the geography that you're presenting. You need to make sure that you're mapping what you're thinking and that you're not really just mapping a proxy for population density or for GDP. And you have to beware the projections, right? You have to understand the fact that maps are not accurate. They're not accurate when we're comparing the whole globe. If we look at the United States, it's accurate to itself. But if we look at the United States as being compared with South America or Africa, it's not. So beware of those things. Maps are great, but we surrender a lot of our control that we come to love when we're building a visualization to really illustrate what's important, because we can't pull that lever of changing size or shape or location of a data point. Now, when we combine the maps with other graphs, they can become very, very powerful, which we'll look at in a future video. Thanks.